Hello everyone, thanks for coming to our talk about building a social, informative, open domain dialogue agent. How did we build a social chatbot that talks to thousands of users a day about anything in the world? It turns out the kind of open domain dialogue you might see in something like, say, the Alexa Prize, where our social bot Chirpy Cardinal plays second, is really hard. Not only can conversations stretch upwards of 15 minutes, the user can bring up anything in the world as a topic of conversation. But just being error-free isn't enough. You have to also have emotional intelligence and a rich personality. Here we detail 3 steps to having a good open domain dialogue. Number 1, an extensible design prioritizing stability. Number 2, integrating neural generation into a symbolic setup. And number 3, recipes for being a good conversational partner. Number 1, an extensible design. We model dialogue as a series of sub-conversations. Each sub-conversation is handled by a module called a RG, or response generator. RGs handle a specific topic grounded in the outside world, like movies or sports, and some handle any possible topic to support open domain dialogue goals. To enable mixed initiative, we provided just a navigational path in the form of a dialogue tree. But when users deviate drastically, we either try to change the topic if we know what they want to talk about, or use a neural handler to deviate strongly from the tree. We can spend an arbitrary amount of time away before returning to our underlying structure. Number 2, integrating controllable neural generation. Can you just use a deep neural generator for this entire task? State-of-the-art LMs like BlenderBot and Mina can be super fluent, but it's really hard to be coherent over a long period of time. In addition, latency can exceed 10 seconds in certain cases. How can we combine the fluency of neural text generation and the controllability of rules-based systems? We propose 2 ways here. Number 1, prefix-based conditional prompting lets us start a sentence with a scaffold and let the model take control. This allows us to control the intent of the generation while maintaining fluency in unusual situations. We distill BlenderBot to 9 layers and reduce latency to 500 milliseconds. In addition, we use a novel infilling technique, applying a fine-tuned BART model to fill in emotive templates with a neural network, allowing for slot filling without structured data. Here's a representative example. We use neural generation here for casual acknowledgements, infilling for emotive salient statements, and structured data to ask targeted questions. Number 3 is being personal. To achieve truly social conversation, a social bot has to be a good conversational partner, empathetic, supportive, and interested in what its human partner has to say. Here's a sample of 2 recipes that aim to get closer to this goal. One of the biggest reasons why people talk to chatbots is to vent, talk about stuff they're not comfortable talking about in real life, or just to complain about what's going on. But standard approaches can suffer from neural toxicity. We draw from active listening techniques in our personal issues RG to be empathetic, incorporating neural generation in a controlled way. Being up to date, neural generators know a lot about what they're trained on, but real humans want to keep up with the real world. And it's the subject of all of our conversations. To address this, we integrate with real-time news, partnering with The Guardian. We bring up news both in context and based on breaking news, allowing users to have a fluent and rich conversation by using neural QA and neural responses to talk about any possible new article that might come up. We detail many more recipes for being personable, along with infinitely more details and design decisions in our paper. So thank you so much.